Hello, my friends. Most of us believe that quantum mechanics is simply a theory that describes subatomic particles, tiny, invisible to the naked eye. But no, quantum mechanics is far more than that. It reaches beyond what we can imagine. In physics, quantum mechanics describes a world where events happen randomly, a world where nothing is truly predictable. That means, in some sense, it denies determinism. When you try to observe the tiniest particles in nature, you realize something strange. You can't know everything about them at once. A particle might be in many places at the same time, or it might not be anywhere at all. It can disappear and reappear, as if it slipped in and out of reality. In Schrödinger's famous cat experiment, when the box is closed, the cat is trapped in a strange state. It's not just alive, it's both alive and dead. Just like a particle in superposition, it's spinning up and spinning down at the same time. But the moment you observe it, you see only one version. Now ask yourself, are we the ones choosing what we see, or are the particles deciding for us? Perhaps it's not us who choose the outcome. Maybe it's the quantum world that decides. Richard Feynman once said, "No one really understands quantum physics." And he was right. Once you enter quantum mechanics, you enter a realm of uncertainty, a place where nothing is impossible, but nothing is ever certain. Not even death. That, my friends, is quantum immortality, a strange possibility that you might never truly die. One of the most mind-bending discoveries in modern physics comes from an experiment so simple it could be done in a school lab. It's called the double-slit experiment. At first glance, it looks harmless. We shoot tiny particles, like electrons or photons, toward a barrier with two slits. And behind it, we place a screen to see where the particles land. If particles were simply particles, you'd expect them to go through one slit or the other, leaving two bands on the screen. But that's not what happens. Instead, something strange occurs. Over time, a pattern of interference emerges, a pattern made by waves. Waves? Yes. These tiny particles behave like waves that interfere with themselves. Peaks cancel peaks, troughs cancel troughs, as if each particle had traveled through both slits at once. This makes no sense in classical physics. But then comes the twist. Curious scientists tried placing a detector at the slits, a way to observe which path the particle took. And just like that, the interference pattern vanishes. The particle starts behaving like a classical object again. Just one particle, choosing one slit, one path, one result, just like you'd expect in the everyday world. What happened? Nothing in the setup changed, except that we tried to observe the particle. That act alone, the observation, collapsed the wave of possibilities into a single outcome. The particle decided to stop being a wave the moment we looked. At first, it's as if the universe whispered, "I show you what you expect, only when you're watching." This tiny experiment changes everything. It suggests that reality itself is not fixed until it is observed. In other words, your act of observation creates the world you see. And that is a terrifyingly beautiful idea. So here's the question. Why does observation change the outcome? Does reality somehow know when it's being watched? This brings us to one of the most controversial debates in quantum physics. What causes the wave function to collapse? Some physicists believe it's just a result of interaction. When a quantum system interacts with its environment, its superposition breaks down. Others argue something even more radical, that consciousness, your awareness, your mind, plays a role in shaping reality. Think about it. When you observe a quantum system, you're not just passively looking, you're actively choosing what to look for. And that very choice may force the system to decide its state. This idea is uncomfortable. It suggests that your mind is not separate from the universe, but an integral part of it. Let's revisit Schrödinger's cat. The cat in the box exists in two states at once, alive and dead, until someone opens the box and observes it. But here's the twist. What if two different people look inside the box at different times? And what if they see different outcomes? One sees the cat alive, the other sees it dead. Who's right? From a quantum perspective, both may be right, in their own version of reality. Their observations don't just reflect reality, they create it. This leads us to a disturbing yet fascinating idea. Reality is not objective, it's subjective. It depends on who's watching and when. This doesn't mean anything goes, or that truth is meaningless. But it does mean that truth may be fragmented, spread across many minds, many perspectives, and perhaps many worlds. So now, let's return to you. You're listening to this video, you're observing it, and that act, this moment, may be shaping the reality you're in ways you can't yet comprehend. Maybe reality isn't something out there to discover. Maybe it's something you're helping to write, line by line, measurement by measurement, thought by thought. And that's the beauty and terror of the quantum world. Let's imagine a strange experiment. You place Schrödinger's cat in a sealed box. You ask two different people, unaware of each other, to observe the box at separate times. They don't know what time it is. They're in isolated rooms. They both check the box and write down what they saw. Now here's the twist. Person A says the cat is alive. Person B says the cat is dead. Who is correct? You weren't present. You don't know who looked first. You only know that two people had opposite experiences. So, which one is the real reality? Most of us would assume someone is lying, or that a mistake occurred. But in quantum mechanics, there's another possibility. Each person observed a different branch of reality. Each version is valid in its own world. From their perspective, what they saw was true, it was real, but it was real only for them. You, the outside observer, decide to check the box yourself, and what you find doesn't match either account. This drives you to doubt everything. You wonder if reality itself is somehow personal, crafted by your experience, bound by your perspective. The human brain doesn't like this idea. We crave consistency. We want truth to be singular, objective, universal, not fractured and shifting. But quantum mechanics doesn't obey our comfort zones. Instead, it suggests something radical. Reality isn't absolute. It's created in the act of observation. And each observation forms a new branch of the universe. This means two people can see different truths, and both can be right, from within their own quantum paths. If that's true, then your entire life, everything you've seen, heard, felt, is a branch, a version, one possibility among many. And maybe, just maybe, there are countless other versions of you, in countless other realities, experiencing life in completely different ways. Each time a choice is made, a path is taken, or an observation occurs, the universe splits. In 1957, a young physicist named Hugh Everett III proposed an idea that shocked even his colleagues. Instead of accepting that wave functions collapse into a single outcome when observed, he asked a simple, yet powerful, question. What if they don't collapse at all? What if, when a quantum system faces a choice, every possible outcome actually happens, but in different worlds? This is the many worlds interpretation of quantum mechanics, and if it's true, it changes everything. Imagine this. You flip a quantum coin. In one reality, it lands on heads. In another, tails. In Everett's view, the universe splits at the moment of that quantum event. Two versions of reality emerge, one for each outcome, and the same thing happens for every quantum event. Every particle measured, every atom that moves, every choice you make. An unfathomable number of worlds branch off every instant, each carrying its own version of reality. This means that right now, there could be countless versions of you. One where you're listening to this video, one where you're not, one where you turned left instead of right this morning. These versions don't interact. They exist in parallel, forever split, but forever real. The beauty of Everett's theory is that it removes mystery. There's no need for wave function collapse. No magical choice made by particles. Just universal evolution, a constant unfolding of all possibilities. But there's a price. If this theory is true, then every tragedy you avoided may still have happened to another version of you. Every mistake you didn't make, someone else did, in a parallel world, just like yours. Some find this idea comforting, others terrifying, because if the multiverse is real, then nothing is impossible, and everything is inevitable. Still, the theory has a certain elegance. It restores determinism by saying the universe doesn't choose just one path. It walks all paths. Every version of reality exists somewhere. Every choice is honored. Every possibility is real. You are not the only you, and your world is not the only world. So the next time you hesitate before a decision, remember this. In another universe, you've already chosen. Now that we've stepped into the world of many universes, a strange possibility begins to emerge. One that feels almost like science fiction, but comes directly from quantum logic. It's called quantum immortality. Here's the idea. If every possible outcome of a quantum event occurs in a branching universe, then even life and death decisions must follow the same rule. Imagine a quantum experiment tied to a lethal mechanism. It's triggered only if a particle lands in a certain state. From the perspective of an outside observer, there's a chance the mechanism goes off. There's also a chance it doesn't. But what about the person inside the experiment? In Everett's multiverse, that person only continues to exist in the branches where they survive. Because in every branch where they die, their consciousness can no longer continue. It's only in the surviving branches that awareness goes on. This leads to a radical conclusion. From the first-person perspective, you may never experience your own death. Even if the probability of survival is astronomically small, there will always be some branch in which you live, and that is quantum immortality. It's not true immortality. Your body still ages, you still face danger. But at every near-death moment, your consciousness might slide into the timeline where you just barely survived. Think about it. Have you ever had a brush with death? A near accident? A moment you thought, I shouldn't be alive right now? What if, in countless other branches, you didn't survive? What if the you listening to this right now is the one version who always makes it through? Statistically, it seems impossible. But in a multiverse of infinite branches, even impossible things become inevitable. This may explain why so many people survive against staggering odds, why we often feel like we've cheated death. In countless other realities we didn't, but our awareness, the thread of self, continues only in the places where it can. That doesn't mean you're truly immortal. There will come a point where no physical branch can support your body, your brain, your cells. But until that moment, you will only ever find yourself alive. It's a haunting idea. It feels like a glitch in the matrix of existence, but it's grounded in logic, in math, in quantum law. The universe may be full of death, but the only branches you'll ever know are the ones where you survive. So let's pause, take a breath, and ask the question that truly matters. What does all of this mean for you? If quantum mechanics is correct, if the multiverse is real, then you are not just a person, you are a pattern, a wave function, a flicker of possibilities sailing through an ocean of probabilities. You are not fixed, you are not final, you are in motion. Every thought you've ever had, every decision you've ever made, has sent ripples through the quantum sea. Every time you opened a door, another version of you walked through the other one. But you, the you in this moment, you're the branch that kept going. You're the version that survived, chose, remembered, and that's the one you experience. So what is reality? It's not some concrete block of facts. Reality is a mirror, reflecting your presence. It's not fully formed until you arrive, until you look, until you observe. Without you, the observer, There is no collapse of possibility into experience. No now, no this, no world. Maybe that's why, no matter how much science explains, there's always something left, unspoken. Because reality isn't just out there, it's in here, in your eyes, in your questions, in your attention. As the physicist John Wheeler once said, the universe does not exist out there, independent of us. We are inescapably involved in bringing about that which appears to be happening. It's a radical thought, but maybe the universe only becomes real when you look at it. And so, this is not just a story about particles and probability. It's not just about wave functions or Schrödinger's cat. This is about you, and the way you collapse infinity into this one, fragile, beautiful now, right here, right now, listening to these words, existing. So as the multiverse branches, and your possibilities expand in all directions, remember, you are the only one who will ever see the universe from your eyes. You are the meaning in the math. You are the measure that makes things real. And in that way, you are the center of the universe. If you've made it here, perhaps something in you resonates with the unknown, with the mystery, with the idea that reality is more than what we see. Maybe you too have felt, in the quiet of night or in the chaos of thought, that there's something greater just beyond the veil. Thank you for walking with me through this strange and beautiful universe. If these ideas stirred your curiosity, if they made you pause and think differently, then I invite you to stay on this journey with us. Subscribe to the channel. Join a growing library of minds who dare to explore not just space, but the space within. Because the story of the universe is also your story, and it's only just begun.